Thank you so much. Hey everyone, hope you are all doing good. Today I'm this is like a career talk. It's like a casual discussion, right? It's not like I'm like going to tell what you do and what should you not do. It's like what my experiences are and how the AI is evolved over the period when I started in the industry, and now how it is evolving, and in future what skills that we have to learn to to be competitive in the market, right? And as a student, what skills that you have to acquire to be up to date with the AI, because AI is like everybody is hearing, right? AI is like creating new waves every day. So let me go over like how the AI evolved over the period of time, and later we can discuss some of my personal projects, like how I used AI in my enterprise level companies, and then what are the how we are currently working with AI, right? And also how we are utilizing AI when we are doing our daily job, right? So these are the few things that I want to share with you. And also it should be an interactive session, I feel like more participations from you guys as well, so that I can understand better. It's been like 8-9 years in the industry, so I'm not very familiar with what exactly the student curriculum is going on. So it's like if you are very active and it's conversational, then I can also get to know what exactly that you guys are looking for, and also how what are the skills that I can, or else what are the things that I can give from my side to you that can be helpful for you. Yeah, let me share my screen. I have a small presentation, so don't get bored with that presentation. But yeah, it will be a very not I won't take much time in the presentation because these are going, I know. Let me share. I don't know which screen I'm.
Actually, your screen is not visible yet.
Okay, I don't know. Like it's lagging. Share this window. Okay, I'm not sure which window you are seeing. Okay, you are seeing my wrong window. Let me
Yes, yes.
stop sharing. Let me share a different screen. Are you able to see my screen now?
Yeah, yeah, please go ahead.
Which screen you are able to see? The presentation screen itself, right?
Yes, yes.
Okay, cool. Great. So before going to start the presentation, like I would like to know few things from you guys as well. Like as a student, like how you are using currently AI, like in your day to day work, how you are using the AI. Is it like in projects how you are using it, or in academia how you are like taking help from the AI to gain knowledge or do your projects. So like anyone can come up and speak like how exactly you're using it or benefiting from AI. Bhadra commented that like he's using ChatGPT every day in his projects. That's great. And any more participations? You can come up and speak as well, like because that you have to do, right? When you're going to give your interviews and all, you have to like lead your fear and come up and speak. Here, like we don't judge, anyone won't judge, right? So you can like feel it's not like a something that question answering. It's like a conversation that you're seeking guidance from someone who is been in this industry. That's all. Okay. So I use Gemini for help and video creations. That's great. These days, like people like using AI tools from Gemini to make short videos and all, right? Okay, chalo. Let's move on to the presentation. Okay, someone else using Claude Opus. Okay, it's like good that I'm hearing so many LLMs, right? Somebody
Good
is
afternoon, sir.
sorry. Yeah, good afternoon, Jagdish.
I am using a ChatGPT Gemini Perplexity by creating the PPTs like a Gamma. We're using lot of things. Are using main projects are related IoT.
Right.
That's why I'm using lot of AI agents like notebook LLM for studying purpose. That's why useful to the real world.
Yep, yep. So that is good to hear from you. So exactly. So like as he mentioned, right? Earlier we used to have these PPTs from, like, currently the PPT that I'm presenting, right, is also made with Gamma, that Jagdish just mentioned. Like, he's also using the same Gamma tool to create PPTs. That's good to know. And also, we used to create manual PPTs. We used to create manual notes, everything. Now with the help of AI, we are using all these tools, existing tools, uh, you know, to speed up the process. Okay. So let's talk these things at the later of the presentation. I'll quickly wrap up the presentation in 15-20 minutes, and we just discuss. Like, you can ask me questions like few things. Like as a student, I also have many doubts, like what exactly I'm doing, like what exactly people, if you go to software engineering or AI data science, what these are exactly working on, and how the day-to-day life, and what projects these guys used to work on, like why, like, how they are changing the world. All these things will be there. Like during our college, we used to work on projects, right? And how exactly different these projects from what we do at companies, right? So let's take these things at the end of the presentation. You freely interact with me. Whatever guidance that you want or needing, I can help you with that. Okay. But for that, you have to give me a promise that you would be conversational and you have to talk to me. Okay. So let's start. So evaluation of AI in industry. So this presentation, like basically what I want to cover is how exactly the AI is evolved over the period. Okay. How exactly the industry adopted, not academia. Academia is very advanced to the industry. So usually what happens is industry, first everything got introduced into academia as a research projects. Then if the whatever developed in academia, if they are like, worth generating some money to industry, then industry adopts these things and, create a projects or, products out of it, and, get it to the every user. So I'm not talking about the academia. I am talking about how exactly the industry is, taking AI to the next levels. Okay. So yeah, let's discuss that in this presentation. Before that, let me give you a small intro. I think like Sensei team already given a very good intro. I can't give that great intro for myself as well. So yeah, I'm Sri Ganesh. I'm working as a senior applied scientist at ServiceNow currently. Okay, so I've been working with ServiceNow for past 2 years, and previous to that, I worked with Oracle in OCI department, like Oracle Cloud Infra, for almost like 2 years. And I have been like few other multiple organizations prior to Oracle as well. So during these tenure, mostly I have started my career with the data science and AI. Okay, I started my career in 2018. So then I started my career with AI itself. Okay, I started with a startup, and so then I started with computer vision. At that time, computer vision was very famous. Okay, very popular. So I started with computer vision projects, then move on to deal with multiple projects in the computer vision, and I have addressed multiple domains as well, like medical sector. I have did a project, retail, etc., etc. Later, I moved to Oracle. In Oracle, I have like developed projects at scale, that caters like millions of people. Okay, there also I started working with computer vision, and then later on moved to like NLP text side. Okay, since like from past 5 years, I'm completely working with text data, and since they're like there onwards, I have started using these LLMs, all this stuff. So that's a quick intro about me. If you want to know more about me, you can go to LinkedIn. You can like know more about me, and you can connect with me as well there. If you want any personal help, you can ping me anytime. That's okay. Move on to next slide. So yeah, so how the industry evolved. Okay, first, like rule based AI, like it's all started with rule based AIs. Okay, there are four different eras that AI started advancing. So started with rule based AI. Rule based AI is nothing but simple like rules and all. They created systems out of rules, and then they deployed those systems. Second, it was statistical AI. They it's like advancement, right? Like rule based AI is there, then it moved to the progression happened to statistical AI. They introduced some statistical models with probabilities, finding outcomes with probabilities, and then they moved on to classical ML, classical and web ML. There they introduced like much more advanced algorithms, and then finally they moved to deep learning. There we have computer vision based models, and then text based models, and then further on they moved on to generative AI. Okay, so generative AI, currently we are at generative AI era, where like we are generating the things. And prior to that, it's not a generative era. It's like a discriminative era. Basically, we have to discriminate between things. So I'll like explain what exactly these are. So this is how AI got evolved. Move on to the next slide. So rule-based era, as I mentioned, like rules in the rule-based era, what engineers were doing in the offices, right? So basically, I have a data. Okay, so I'm going to like expert in the domain. For example, I want to develop a business banking, like I want to develop an application or ML model for the banking sector. So I have to talk to like a banking employee from bank, or the person who knows about banking well. So I have to talk to them. I have to sit with them. and I have to know the rules, like what exactly I have to do, right? So how many transactions happened, when you think the transaction is fraudulent, is there any, patterns over there? With if and else conditions, I will design my system. If something is happened, like if the transaction happened around 12 or 12 p.m., like 12 a.m., so it's like a mostly fraudulent transaction, something like that. With some conditions, we used to create systems, if else conditions with systems. These are mostly deterministic systems. When I say deterministic, the outcome is like, it's not changing. It's completely, 100% that outcome will happen. So that's what deterministic means. Okay. So this is where rule-based AI started in 1970s and 80s. So for example, like IBM, they create a big rule engine in place. They kept in place, and then it has a lot of conditions. It's like a tree, right? Every time you have a question, then it has to bisected into two options. One is like, true or false, right? Next, the second question also, bisected into two things, true or false. So in this way, they have a lot of rules in place, and they created a big engine out of it. So that's how early, AI worked in the industry. Okay. Later on, like it's moved to statistical AI. Okay, statistical AI is like a predict. It's not like a rule-based AI. It is like a predicting things based on probability. Okay, so for example, given a word, for example, spam detection, right? Given us a word in a mail, then you have to predict whether the given, like how probable this word is, like a spam or unspam, something like that. Like you have to determine the probability of each word. So spam detection things use these statistical AI approaches. The methods that are present in these statistical AI are like naive Bayes, hidden Markov models, and Bayesian networks. So these are the few algorithms that are based on, like, depends on the statistical AI, or probabilities, finding the probabilities, and determining the outcomes. So these are the few methods, and what engineers used to do at offices. So they used to collect the data. So earlier they have to go to the expert, domain expert, and then they have to sit with them. They have to ask every information about how to create this rules, right? Now they don't have to put that much effort into this. They have to collect the data. They have to connect with the domain expert, and they have to get the information. That is like not they don't have to sit like much of the time with the expert, right? So then they collected labels with the experts, and then they collect the historical data. Based on the historical data, they used to create these probabilistic models where it will identify the probabilities of upcoming event based on the past events that was happened. That was the statistical error happens in 1990s, 80s, and 90s. Then like classical ML, right? So during these period, uh, they build like models like SVMs, linear regressions, logistic regressions, decision trees. These were the algorithms that has been came up during this era. So what engineers used to do is like they build structured label data sets. They create the data sets by themselves, and they mostly work on extracting features. Let's say you want to create a model, that predicts something. Let's say house price prediction, right? That is very famous data sets. So you want to do something, so there will be a lot of parameters that can use, right? House size of the house, or number of bedrooms in the house, or locality, or etc., etc. So there can be like numerous features that can be used to determine the price of the house, right? So now in that numerous features, let's say 10,000 features, all the 10,000 features are not useful to determine the house, right? So some can be like eliminated. So this is called like feature engineering. So there people used to like see these features manually and see what are the exact features that we required for this, which features are impacting the price of the house, right? So they identify these features, they include these features into the data, final data, and they eliminate all the unnecessary or redundant features from the final data. So this is called feature engineering. That's what they mostly do. Then they feed these data to these models, whatever I just mentioned, like SVMs and k-means clusterings or decision trees, etc., etc. They feed these data to these models, and these models create a boundaries. Like basically, they create a decision boundaries, or they make the decision based on the trained data. So that's how they use classical ML. People used classical ML to train the systems, and with a vast amount of data that is available. Moving on to classical, next to the classical ML, like then internet got exploded. So there is Google, there is Amazon, there is a lot of data. Internet is available to everyone, and so the oil to the fuel to the AI is nothing but data, right? Now after post 2000s, the data is available, vast data is available, right? Now the fuel is available for the AI. So now we can train a bigger models with lots of data, billions of data. So that's where the scale of machine learning happened. Like they want to scale it to earlier it's like a few people used it, but when companies adopted these ML models like Google and etc., they want to scale it to the millions of people. The models have to run, taking inputs from the millions of people and predicting them and giving outputs to the millions and billions of people, right? So that's where the scaling is happening. So what engineers used to do. So this is the era where big data got introduced, distributed systems got introduced, and they are used extensively in the industry. Okay. And what is the example for this? For example, Netflix recommendation engine is like a big example for this. Amazon, their recommendation system, all the recommendation systems around that time, uses these algorithms. And also, of Google page ranking algorithm. This is not exactly the classical ML. It's like a probabilistic model that they developed, but it's kind of a it's kind of a middle ground between this probability and machine learning, right? Then gradient boosting, logistic regression, collaborative filtering. These are the different models that got introduced or that got used in the industry. So these models got introduced very old, 80s, 90s. These papers got published in the academia, but industry, it took them into the real time in these eras. Okay. So next, move on to next transition, which is deep learning. So this is where I also got started my uh, industry experience, right? So deep learning era. So what deep learning era used to do? So earlier classical ML, you have to handcraft the features, like you have to do the feature engineering by yourself, and you have to come up with good features and use these features to develop the models, right? Now in deep learning, you don't have to do this also. The models themselves are capable of extracting features automatically from the data. So you throw the data at the system itself will extract the good data from the data that you thrown at, and then it try to create the pattern, understand the patterns, and draw the decision boundaries. For example, classification, if you want to identify cat and dog, right? So now you have to draw a decision boundary between cat and dog, right? So basically that decision boundary will happen on the data level. It takes the data, it extracts the useful features, and it draw a boundary. If whatever input is one side of the boundary is like cat, the other side is dog, something like that. It used to draw decision boundaries by extracting the features automatically. So in this era, mostly CNNs, convolution neural networks, which mostly works on images, that got introduced. All the applications around images at that time used CNNs around 2015, 20 era. So mostly CNNs are used for images, and then recurrent neural networks and LSTMs. These are mostly used for text-based data. Like for example, you want to do a spam detection on texts or text classification. For example, in the comments, right? Amazon, you see the comments, and each comment has some, is good or bad or opinion, or else 5-star rating, right? So you just provide the text, they will run these comments with these RNNs or LSTMs, and they categorize these texts into 5 categories, like good, bad, was something like that, and they used to classify things. For that, they used RNNs, and RNNs got introduced first, and then later it was improved and created LSTMs. Okay, so these are the few things that happen. So images, audio, video. Not video. Video is nothing but frames of images, right? Images, audio, text. All these three unstructured data got used in the deep learning era, right? And next, NLP and transformers. So post CNNs, and so if you see here, there are RNNs, LSTMs, which mostly works on text, but there are issues with these models. Okay, so I'm not going deep into these models, but there are few issues. For that, they created something called transformers. This got introduced in 2017. Transformers got introduced by Google in 2017. So they have a special technique called attention. So that got introduced in this paper. So post this, BERT, GPT, ChatGPT, whatever you are using, all the large language models like Claude or GPT or Gemini, all these models are like, the foundation to these models are nothing but attention transformer. This is the the base for all this development happened. Okay. So at that time, I think back then, transformers are not that like useful. People use transformers for text, for classification, but mainly but. So it basically takes text and create a representation for the text, and later it used for classification, etc. So they in BERT also, like in transformers also, there are two things. One is like discriminative models and then generative models. Discriminative models are just for classification. So you give text to model and it'll just classify things. Okay. So whether true or false or spam or non-spam, something like that. And then generative models. These are capable of generating new text. Okay. So GPT got introduced, then GPT got introduced, and based on the generative model. Okay. So then it got exploded in 2022, I guess. And then you saw what happened after that, right? Everyone is using ChatGPT or all these large language models for all the use cases, like coming from text summarization, text classification, text rewriting, tone detection, generating videos, generating images, generating writing resumes. All these things are like now we are using LLMs, creating PPTs, etc., etc. So the new era started post ChatGPT, we can say. So why? So if you think of this, like transformers, which is a base or heart of the LLM architecture, was introduced in 2017, right? And why it was not known to the people or not known to the outside people apart from the core research teams, why it is not like known to everyone, right? So at that time, like scaling these kind of models is very hard, right? So each model have like trillions of parameters. Like running these in a system is impossible, right? GPUs also available, but running these big models in GPUs that are available at that time is like nearly impossible. Then we have clusters of GPUs. They used to run these models in clusters, like 10 GPUs in a cluster. They used to run the models in that 10 cluster. But still, like generating one response used to take time. Now think about like scale. Like you are using ChatGPT every day. Like every day, millions of requests are coming in. Now, like the scale of hardware is like impeccable. Like you can't even imagine, right? So what ChatGPT told to the world is that you can scale. Like algorithms are there, data is there, but scaling no one knows. But OpenAI introduced to the world that you can scale, you can serve it to millions of people without any latency. If you have latency, you don't work, right? Like you don't use these things. But these chat OpenAI showed that you can use like scale these models at scale. Later got adopted, like industry now knows like how to scale these models, and then onwards, like all these models, like all the companies knows that trick, and then like everyone is introducing these models. Basically, it's like a hardware how to scale these models. That's what they learned after 2022. Post that, agentic AI started. Right now, like we are in the agentic era. So now, like you use one chat GPT, right? Like think of like there are 10 chat GPTs like communicating between themselves. So there is one chat GPT which is like a master, and then there are 10 chat GPTs which are like students doing expertise in different tasks. Now the master will tell like what master will understand the question from the user, and directs to the respective student to do the job, right? So now it's like agentic systems, like where they will take decisions themselves and come up with outcome. Now then we have a multi-agentic systems. There are like not two agents. There are like hundreds of agents talking to themselves, and like there will be one goal, and they're all these agents working on that goal to fulfill that goal. Okay. So now currently we are in generative AI and agentic era, right? So now I'll stop here. So this is like an introduction, like I want to give, so that you will also, I don't want you to know all this stuff. I just want you to know like how exactly the transition happened, right? These are the things that have happened over the period. Now, I want to like, I don't want you to think or memorize all this stuff, right? Just have like, okay, this is how it was transition. Now is the major part. Like, I want you to interact with me, like what exactly, you want to know from me, right? Before that, I'll give few use cases like that I'm working on, like what exactly I used to do in my projects, what exactly projects that I did recent past with using these models and all. Okay, and then we can go, like I can take up questions from you, or we can interact with each other and to know more what you want to know. Okay, so now autonomous, like what comes next, like the future of AI. Like right now we know what happened, but we don't need what happened. We just like we learn what will happen, that we anyway learn. But we have to be ready what is going to happen in future, in next 5 years, or next, like let's say you are a final year grad. Now you want to know what happens next year because you want to get placed into that company, like into the companies, right? Then you have to be ready with the skills, like what skills that companies are looking for, and how the industry is changed post ChatGPT. Right now, interviews become easy. You like everything, like you can learn from GPTs and all, right? So that all we discuss. Okay. So currently we are at autonomous multi-system agents, right? Like LLMs can write code, LLMs can take decisions, LLMs can write better summaries than us. LLMs can write better mails than us. LLMs can write better stories than us. LLMs can create videos that are like probably not better than us. Like they are coming up. Okay. So now workflows, like industries, enterprise grade companies mostly use workflows in every way. Like and now AI is like using that workflows. Like they are using workflow like AI extensively in workflows. Like for example, in ServiceNow, take an example for ServiceNow. ServiceNow is a ticketing platform. Now what happens is a customer has some issue, like you raise a ticket or you raise a concern in Zomato that you're not, like your order is not good, or you raise a concern at Amazon, like your order is not good. Now there are hundreds of teams that are working in that company in the Amazon, right? There will be few teams that are like 100 different teams working on 100 different things, but your whatever issue that you have raised will be will be addressed by one team. Right now, you have to use AI systems to identify this. Earlier, what used to happen, there will be a middleman who is like taking the issue from the user, and now he will escalate it to a different group. There, that group will see whether they can solve it or not. Then they will escalate it to a different group. Then they will again understand the problem, and they will escalate it to next group. And there also solution might be, we might get solution, might not get solution, then it might needs to be escalated next to. So this whole process used to take weeks, like 2 weeks or 3 weeks or more than that. Now with AI in place, now AI knows what exactly everything is doing. So now when the question comes in, there will be a support engineer. He will be looking at issue, and he will give that issue to AI. AI will tell what exactly team that is working on this, and you can go and contact them. So now the resolution is happening in 2 days or 3 days. So this, like, people are saving like weeks of time with just one AI model to resolve their issues. That is how. And in workflows, right? Workflows is nothing but chain of events that happen. Like for example, you want to apply a mail, you want to apply, you want to send a note. Like for example, if you're in industry, you want to take a leave, right? I will go and open the website and apply a mail, and then that will send a notification to my manager, etc., etc. That used to happen, right? Now you don't have to do anything. So you have agentic systems in place. When you write in Claude, you can directly mention that I want to go for a leave for 10 days for this so and so reason, and it will directly apply the mail in your whatever website that you use, and then it will send a mail to the manager, and then it will get approval, and then it do everything for you. You don't have to do anything now, right? And multimodal foundation model. So basically now not only text, videos are generative, right? So you can generate any video. You can create create all sorts of videos with your prompts, right? So multimodals are coming in place. They're capable, or single LLM model is capable of addressing text data, image data, audio data. So earlier this is not the case. There are special LLMs for each of these use cases. You have a CNNs for text, RNNs and LSTMs for CNNs for images, RNNs and LSTMs for text, and there are CNNs can be used for audio as well, but they used to have a different pre-processing mechanism. So now with multimodal, all sorts of data can be consumed by single model and do anything, right? You give a prompt, it is generating image for you, right? So then human AI collaboration, real-time adaptive intelligence. It's like you give something, right? So you ask for something, LLM gives you answer, then you feel like it might not correct, right? Then you say like modify it. This is not this is not the correct, or this is like slightly different. I need a different version of this, right? Then what happens is models will take this feedback as a take this information as a feedback and adapt to the conversation, and they give better answers, right? This is all happening real time. And human AI collaboration. Now humans are in place, so like it's basically interaction, right? You are interacting with AI as like how you are interacting with human, and you are like asking all the sorts of questions that you have. Earlier you used to go to Google search and you used to search for everything. Now you don't have that any, like you don't need anymore, right? Recently a LinkedIn post, I think, I don't know how many of you are using LinkedIn, but recently I saw a LinkedIn post where so in the industry, Stack Overflow is the gold standard. Like whatever question that you have, you used to go to Stack, you used to do a Google search, and Google search will used to give the Stack Overflow links, and then you used to go to Stack Overflow, and then you get solutions over there. Now, recently, like last 5 months ago or 2 months ago, the Stack Overflow new questions asking in Stack Overflow got zero, literally zero, right? That is like over the decade, Stack Overflow is a gold standard for the software engineers to go to. So it's like a go-to platform to get solutions for their questions. Now there are no one asking any solutions in Stack Overflow. Like everybody is using these AI models and getting the solutions. And also with Stack Overflow, what you have to do, you have to ask a question, then you have to search for many pages, and then you have to get the solution. Now it's not anymore. You just have to go to GPT, you ask question, it gives answer. If it's not correct, you again like prompt it in a different way. Then this happens till you get the correct answer, right? So this is how like currently the like things are happening. So now what students should learn, what I think, so fundamental, like software engineering DSA, that is for sure. Like you can't skip the DSA part. So because like there should be a common, like you learn LLMs, you can create generative AI models, right? I trained foundation models. Okay, I created a large language models from scratch, and train these models on bigger GPUs, like hundreds of GPUs and all. But if I want to transition to a new company, the company will ask DSA as like in first round. Okay, you can't leave DSA. Okay, that is like gold standard. You have to learn DSA, that is for sure. So then after DSA, if you want to go to AI, so then ML fundamentals should be there. So you can learn like what I observed is like many people know how to use AI and creating projects with AI, but fundamentals are lacking. They don't know how to do how linear regression is working, how logistic regression is working, how these decision boundaries are formed, how the CNNs are worked, how like what exactly the image is, like how the pixels are created, and how LA models use these pixels, to decide whether what contains in the image. So these are the fundamentals. What is backpropagation algorithm, right? What is sigmoid? So these are very fundamental blocks of AI. And then you need to have you need to know what is differentiation. Differentiation is like a core thing of AI. Differentiation, integration, probability, conditional probabilities, like Bayesian systems. All these are very fundamentals of AI. So first, people have to have a very strong fundamentals in these areas. Later, they can create whatever projects that they want. But fundamentals are required, because in interviews they don't ask you like what they will ask you what project you created, but they will deep down into fundamentals, right? Because that is the common ground. That is how they can decide whether you know anything or not, because everyone can use ChatGPT and create projects. So that's fundamentals required. Then once the fundamentals are there, then they can learn these things like RAG systems or whatever, like bigger things that we have. For example, like RAG systems, what exactly a RAG system is, how they exactly work, and deep learning. Like deep learning is like a one step above classical ML, right? How images are used, how text is used, and then transformers. So if you want to get good with generative AI, so you have to know what exactly is RNN. So you have to start from RNN cell, and then how RNNs are transformed into LSTMs, how LSTMs are transformed into transformers, how transformers are transformed into ChatGPT, right? This is how you have to know. Otherwise, if you what is exactly the attention? Attention is like heart of all the revolution that is happening. So you have to know fundamentals, why exactly it works, why exactly attention is worked, and etc. Then AI safety evaluation, like this is like a more of a industry standard, like how industry is like transitioning into. People are creating a lot of AI models, but governance is a problem. Like because people can generate anything, but how you can evaluate whether it is safe for people or not, right? That is where this is a crucial, like AI safety. So companies are like prioritizing safety. That is a very good opportunity that we can look into. And then evaluation, like now LLMs can generate anything, but how you have to evaluate, right? So whether the things are generating correctly or not for your use case. Like there are general LLMs like Cloud Opus, Gemini, etc., etc. But industry use these LLMs. But industry has, like, for example, business sector, they have their own data sets. So these large language models can understand the data up to some extent, but consuming these LLMs like costly, right? So then that's why we want to create a smaller LLMs that are task specific. Some small LLM that should be focused on business sector. Some LLMs, sorry, that should focus on like banking sector. Some LLMs health sector. Now the small model size was smaller, and then you can like take lesser resources, GPU resources. Carbon emission will be reduced, and you can save environment also. So that's where the model like mostly most of the companies are focused on. And other companies, basically they are creating applications. Now there are only few companies that are creating foundational LLMs. Like Google is creating foundational LLMs, OpenAI creating, Claude, like Anthropic is creating, and then there are few Chinese companies, they are creating foundational models. Twitter is creating. So these are having a lot of money, and they can create foundational models. But there are more, like, there are companies, like they are big enough companies, like they are billion-dollar companies, but they are not focusing on foundational models, because creating foundation models is very expensive. Now what they are doing is, now foundation models, they are cheaper also. They use the foundation models and creating applications on that. Okay, so currently you use existing foundation models, create applications with that. That is one area. Second, you like, how can you create evaluations for the models? That is one area. How can you create a safety around these models? That is one area, right? Different, how you can adopt these models in different sectors, like banking, real estate, or health, etc., etc. How can you leverage these LLMs to solve a niche problem? So that can be one sector, right? So these are the few things that you can focus on. But start with fundamentals, DSA, mandatory. For AI, basics are mandatory, like linear algebra, ML models, linear, like integrations, differentiations, all these are mandatory, right? Next, what you learn is up to you. Like you want to learn CNNs, you can learn CNNs, or you can learn agentic systems, you can learn computer vision models, etc., etc. That is up to you. But these fundamentals should be there, and that you have to learn. You can't skip them. And somebody is asking, could you please suggest the resources? Yep. So you can, like, for these models, when I started learning, right? I started learning in 2018. At that time, like I used to use Android, YouTube. Like in YouTube, I think you can find the Android videos that are very famous for ML, right? But also for deep learning, there is like Stanford course, like CN 231, I guess. I think that is the one of Fefeli, and there is some other guy, I didn't remember his name, but so that you can use for deep learning. So that will give you the foundation for classical ML and then deep learning. So deep learning, I think there are 5 different playlists. Each playlist covers specific code, like a specific area, like CNN's one course, and then RNN's or text based one playlist, and then recommended systems one playlist, something like that will be there. So those are like fundamentals for you. And also there are YouTube videos, but I don't know, like I'm not sure standard videos, but there are blogs. Now you don't need blogs anymore, right? You can just, like, you can go watch a video, and you understand to some extent. Like you don't understand in the first go itself, but take that and ask ChatGPT. It will give you everything, and you just have to know the names now. Take the name, go to ChatGPT, ask about that thing. It will give you everything detailed. It asks, like, tell me, like, I'm a student, I'm a like kid. Explain me like a kid. Like, explain me it to a kid. Then it will give you everything from, like, very basic. So you just have to know the names. That's why I don't want to, like, make you learn all this stuff. You just have to know the names. So that, take the name, search. That's all. So to answer your question, you can use, like, Android course for classical ML, and I don't know how relevant. I think they are basics, right? They are still relevant. And CS231 endpoints from Stanford for deep learning. So that those are like foundations, at least for me back then. And so now it's up to you. Like you can ask me like few questions, like you think I can address them, or you have any concerns, or things like that. You can bring up to me. We can discuss. So that's all about my presentation. So yeah, now it's like it's up to you how you want to use me, right? So how you want to take advantage of me. So it's up to you now. So like someone is asking top 5 summary of your today's meeting. Okay. Uh, so it's like easy. Like it's basically how how we evolved over the period, how industry is evolved, how industry is using AI over the period of time. Right. So then like what exactly currently the industry is doing, like how exactly we are using AI, right? And then what you have to learn, right, as a student, right? And then currently you have to know these things. What are the things that you have to know mandatorily? And as a future engineer, like what you want to focus on. So like this is all like that I have covered in this meet. Could you someone is asking who are the winners? Winners of what? Winners of these models. How the work life in corporate is it stressful? Okay. Uh it's up to people, right? So we don't know. So it depends on teams to teams as well. So there are times that it will be stressful, but there are times that you enjoy, right? So they are in balance. I don't think like if you are coming to industry that I don't want work, I want to enjoy, right? I want like chill. That then it's not for you, because they are paying money. They'll ask you to work, right? But they should not ask you to work like taking your sleep time as well, right? But there are times that it happens, but not all the time. So sometimes it will be very lenient. Sometimes I used to work for 1-2 hours a day. That's all. So there are times that I used to work for 16-17 hours a day. So it's like if you consider as a whole, then it's like average time you will 10-11 hours. But if you think on the stressful days, like they are really stressful, like you have to stay for 15-16 hours. But if you enjoy, you don't feel stress. Okay, somebody is asking, with so many people moving quickly using vibe coding tools, should we doubling down on fundamentals or building apps with those tools? That's a good question. So the question is about like these are so coming like answering this question, I'll tell you one scenario. Currently in the industry, right? Every company is providing AI. Like they're asking us to mandatorily use AI. They're tracking the AI usage. We have to use AI. When we are writing code, now we don't write code. We ask AI to write code. We just evaluate whether the code written by AI is correct or not. And they are writing better code than us, right? So now in VS Code, right? I hope you use VS Code or PyCharm or whatever, uh, thing that you use. So every IDE is coming with AI. Now everyone is using like AI for their like for writing code in the companies, right? So this is called vibe coding. You write code with AI. So this is vibe coding. Now vibe coding is everywhere. Industry already took over the vibe coding. Everybody in the industry is using vibe coding. So there will be effect on future. There will be some effect on jobs, because vibe coding it's writing whatever people write for 5 days, and like whatever 10 people write a code, it's like AI is doing in a day or in an hour also, right? So people are using, industries adapting vibe coding, that you have to keep checking, right? And also hope you guys also doing vibe coding, right? When you are writing your projects, you ask models to write code, and it used to write better code than us, right? So yeah, I want to, okay, second part of that. Okay, so first part of that question is like, should we use vibe coding, or should we know the fundamentals? I would suggest know the fundamentals first, then like you can create applications, whatever applications that you want to know, right? So fundamentals should be strong. Otherwise, whatever you create, you can't crack interviews, because in interviews they will ask fundamentals. They don't ask you like what product that you created, or how good you created the product. They will ask fundamentals, how you scale the systems, how you develop the models, what is the heart of like how exactly attention works, etc., etc. They use these fundamentals in interviews, so you have to be sure on like 100% on fundamentals. I'm trying to figure out what makes more sense: focus on the basics and building projects from scratch, or lean to my focus on fundamentals. Don't create projects from scratch. Okay, as a student, creates few projects from scratch, but there is a popular saying in industry or in like software engineering: don't reinvent the wheel. Wheel is already created. Now your job is to create an engine, or you have to create a car out of it. Should not reinvent the wheel again, because inventing the wheel will take 3-4 days, and somebody else using the existing wheel and creating application out of it, so they will like move faster. So here you should not reinvent whatever existing. You have to take use of whatever existing and build on top of it. And never like people like in India or in students, the mindset will be like, I'll create something, I'll hide to myself. I don't want to show it to others, because others can steal it, right? So that usual typical mindset that we used to have. But let's not do that. Like whenever you create some projects, publish it. Publish everywhere. Like create a traction. Right? I created this. So publish, like create a paper out of it. Publish in archive. So there is a popular platform called Archive. You can write papers and publish there. Okay. Similarly, you can read from there. Write blogs. So you learn something about it. You go and write blogs, which you get some time. But never hide any information to yourself. Just like go and speak to people. Like share information. Get to know information from them. Right. This is like a era that you have to share. Like if you hide, you are behind. That's all. You want to use I want to study TinyML. What's your suggestion? So you can go with it. You can like but start from fundamentals. If you are like have your fundamentals strong, you can like choose whatever way that you want. Like you can learn whatever you want, but fundamentals should be strong. What is neuron? That is what you have to know first. How exactly neuron is working. Product-based companies versus service-based companies, and what do they work on, and the difference. Okay, so I have experience with product-based companies as well as service-based companies. Product-based companies, they create a product, make money out of it. That's what product companies do. Google Maps. So Maps is a product. They will sell the maps to everyone, get money out of it. That's what product companies do. Service companies, it's like a consulting firms. Like they hire people. Product companies, or there are people like who want to create like for example, I want to create a project. I want to create a startup, but I don't know technical expertise. Now I want to hire people, right? But I don't have that many resources to go in the market, search for the people, hire them. It's a tedious process. What I will do, I have a project idea. Now I have money. I want to do project. I'll go to TCS. I'll ask them to complete this project. Now TCS have some people. They will take up my project and they will complete my project, right? Now they basically, instead of hiring the people for my company, it takes process. That's why I'm going to consulting firms like TCS, Infosys, etc. I'm asking for the people because they already have the people, and I am paying to that people, right? So that's what service companies do. Service companies runs on headcount. Basically, if they have 1,000 projects, like if they have 100 people, every person is working on some project, then they generate money. If there is no one, like a person like me who is not giving a project to the service companies not exist, then service companies doesn't have projects, and then they will run out of money. Then they put people into bench, and then like they will terminate. So this is how service companies works. Product companies, they create a product, they will sell the product. If the product got sold, then they will make money. Otherwise, they don't make money, right? So that's how the difference between service and product. But while we doing vibe coding, we are missing the fundamental parts. Exactly, that's what's happening. So when you do vibe coding, you are creating projects, you are creating products, but the fundamentals are not there, right? So like that's the discipline that you have to inculcate in yourself. That you want to learn basics, like do projects, and also focus on basics. Like I do understand now. Like we take easy way, right? When a professor gives a project, we directly go to GPT, complete the project, give the project to professor, enjoy. So instead of enjoying, 1% of that time dedicate to learning fundamentals, that will help you in future. but fundamentals are like you have to learn. That's all. Use vibe coding to know fundamentals now. Okay, anyway, you're using vibe coding. Now use vibe coding to know fundamentals, to learn fundamentals. Ask LLMs to how to write a neural network from scratch. Right now, you understand the code, or else ask LLMs to explain that code. It will explain. Now understand the English. Now you know fundamentals, and now you will it explaining every part of the model, then ask questions like what exactly this part is doing, why we have to use this, why can't we use, is there any something else that we have. So ask questions to LLMs, use vibe code and to learn more things, right? I'm in second year of it, in second year of engineering. If you're in second year, how would you start coding? Okay, coding is easy, right? For coding, first you basically for coding you have to practice. It's like mathematics, so you can't like mathematics is like that, right? You have to keep on practicing, then only like every problem has a different way of approaching it. So once you solve the problem, then only okay, it can be solved in this way. You can't go to the exam and see the question and it will like blink in your mind and you write a solution to that. It's not like that. You have to solve the problem. If you don't solve it earlier, you can't solve the problem in maths, right? Similarly, programming, you have to practice. So practicing starts with basics like simple strings, lists, tuples, dictionaries. These are the like basic arrays, and then algorithms, sorting algorithms, binary search, etc., etc. You have to start with these basics. Then you have to move to advanced like linked list, trees, etc., etc. But these are the basics. You can like use like platforms like lead code. Lead code like very popular. Like lead code, you can use HackerRank, you can use CodeChef is there, and I don't remember, but these are the platforms that you can use to like start practicing the programming. So practice. So only you can solve the programs with practicing. That's all. There is no other shortcut. And and try to solve one problem every day, or at least 3 problems a week. That's all. Like and also these 3 problems that are very difficult, not difficult, that are like of out of your comfort zone. Like people, when I try to do programming, right, I take my comfort zone. Like okay, string problem, this I can solve. So I solve that, I'll enjoy, like because I can able to solve. But you should not solve the problem that you already know. You have to solve the problem that you don't know, so that you can understand the patterns. So yeah, start with 3 questions in a week of different topics that you already not know, and then go from there. How is the scope of AI after 2 years? So scope of AI after 2 years, we don't know, right? So AI is everywhere, that's we know. But like AI will be there for next like many years. That will be for sure. But how it will be there, that we don't know. Now, last year we have generative AI. Now we have agentic systems. Now we have multi-agent systems, and next there will be something else. So it's hard to predict what will be in next 2 years, but there will be some transition will happen, right? Currently, things are going in agentic ways, like building applications. You don't need larger teams. As a single person, if I know how to use AI, I can create everything. I don't know how to write front end. I don't know how to write back end. I only know AI engineering, right? So now with that knowledge, I can create my front end. Earlier, I have to hire people for front end. I have to hire people for back end. Now I don't need it anymore. I need an AI agent. I just have to prompt it, create me a web page like this, right? I have to give a correct prompt, and I should know programming basics, whether it's writing correct or not, just like for evaluation purpose. And it will write full front end, full back end, like everything it will write, right? So yeah, that's how like currently it's like you don't need larger teams to build products now. As a fresher, what are requirements to get a job? Programming, programming. So that's first. So DSA is mandatory. You have to solve problems, right? Second, like project, like take 1-2 projects. That's enough. Like as a fresher in interviews, they most ask for DSA and then projects. What projects that you do? Know end to end about your projects from basics. That's why I like focusing on basics, because whenever you show some project in the interview, they will ask basics about the project. It's not like a big challenge that you solve. It's about what exactly the basics that you use in the project, and focus on that. Okay, so that's why you need to know programming and basics as well. And like try to do internships and try applying internships, like, create your own open source projects in GitHub. Try to like present yourself into the industry and maintain a LinkedIn profile. Talk to people in the industry, communicate with them, and try to get referrals, because there are, like, some programs, I don't know, like student programs or something in industry that you can also take participation in. So yeah, you have to be, basically you have to present yourself. It's like, it's not like once after completing your graduation you go and search for the job. It's not like that. You have to start presenting yourself to the outside world through GitHub. Create project, publish in GitHub, go and publish in LinkedIn, connect to people, show it to the people, like they take suggestions from them, and ask them how can we improve it, something like that. Once you are starting doing projects, you will get ideas by your own. Okay, this is like this. What else I can do? This, like, I can create it at this website. What else features that I can add? So think like that, so that you can like create everything. What should I do to get a job in top companies like Nvidia as ML engineer? Okay. Uh, so Nvidia and all these companies, DSA is must. So I think first two companies, DSA, they will ask for DSA, all the companies. Then you should know basics. That's all. Like Nvidia as an ML engineer, Nvidia. So they mostly focus on hardware side, right? C, C++, etc. Because they're firstly a GPU company. Right? So for them, latency matters. Right? So they focus on like low level languages, like little low level languages like C++, C and all, and programming is mandatory for them. Distributed computing, but as a fresher, programming, DSA is mandatory. That's all. Like go apply, have some projects, try to take, if like, talk to people in LinkedIn, like connect with people, and if there are any openings for freshers, talk to the people, share your resume, and be prepared with C++, DSA, and that's all. Like nobody asks like fancy questions in for freshers. Okay. I need information about data analytics and the skills which are required for data analytics. Okay, data analytics is also good. So data analytics, it's basically knowing about how exactly you want to present your data, right? Creating dashboards, understanding the patterns in the data. It's like, it won't create the models, but it is like a visualization of the data that you have. Like creating dashboards and presenting it to the people, like, stakeholders, higher ups, like what exactly you are observing in the data and how can we take actions on the data. So that, like, I'm not sure, like there are few tools, right? Microsoft has one tool, like some tool. I'm not sure about the tools on the analytics side, but Python is must. Python you can learn. There are few libraries in Python for data, this analytics like pandas, etc., etc. That you can, like, matplotlib or SciPy or something. They say like you can learn first these things, first base, like learn basics like DSA, then use Python and learn other libraries that are, useful for analytics. I created a custom kernel for old rooted mobile. Could I add it to resume as a project? Will it be work? Yes. So if you create with your own knowledge, add it. Nothing is like a smaller or bigger. Like if you do something good, add it. It's fine. But one suggestion would be when you're trying to create a resume, right? Do create a resume according to what job that you're, like, applying for. Like your resume should not be more than one page. It should be one page. That's all. Don't create a resume more than 2 pages, one page. Okay. So in that, include whatever projects that are relevant to the job posting. Okay. And as a, like, if companies are visiting your campus, then it doesn't matter because everyone allowed to sit in the campus placements, right? So you don't need to have this tailor-made resumes. But when you are coming out, start applying outside jobs, you have to have a resume for every job post. It should be tailor-made. Right? Anything else I missed?
I think that's it. That's it, sir. Sri Ganesh, is that okay?
I think we are over time. Yeah. I just observed.
Yeah. And some question.
Yeah. Which programming language is best for coding, like interview purpose? Also, okay. For this, when you're giving an interview, you can write in any programming language that you are okay with. So they don't put restriction on programming language. Any Python, Java, C++, I think JavaScript also sometimes can be included. In these 4 languages, or else there are few other languages that are coming up, Go, all these. So you can use any one of the language. So you just language is just to run the program. That's all. But your fundamentals are same. Like how you write a string is different in programming languages, but string concept is same in all the programming languages. So you can start with, like, if you don't have any knowledge, you can start with Python. It's easy. So start with any programming language for coding. Okay, for interview, they don't have any restriction on that. Currently, I'm studying second year and having interested in full stack. Okay, so how is the scope for the same in future, like after 2 years? As AI is all over there now, all are suggesting to choose AI domain, also analytics. Okay, I have a slightly different opinion on this. Compared to AI jobs, there are more full stack jobs in the industry, and getting a full stack job as a fresher is much easier compared to getting an AI job. AI is like a mass, like you need a specialization in that, right? It's not like a graduate that can do. So it should like come what companies expertise. Either someone should have some experience in AI, they are preferring them because they already know how to build AI systems, or else they should have a master's in that. So, or else, like, top companies, when the company like ServiceNow, Google, Oracle, these companies, when Microsoft, these companies visit your campus, then they will hire people, right? So they will like pick and push people to different domains, like full stack, AI, few people to AI, few people, like that you can go into. But like in my opinion, full stack has more jobs than AI as a fresher. But as a like full stack will not going anywhere, right? The way how we write programming is different, but full stack will be there. You have to learn full stack, and also if you're interested, how to write JavaScript code, how to use Node, like whatever language. Like if you use Python, you have to know Django or Flask. If you use like Node side, you have to know Express.js, like JS stuff to write backend, and you also know front end stuff, like how to use React, all this stuff, Flutter, etc. And so you have to know fundamentals. Then you use vibe code, like people ask these things in interviews. Then coming to industry, they need full stack developers, but they use AI to write these backend code, but still you are in place. You have to monitor how they are writing, right? So it will be like relevant in next like 5-10 years. But how it will be transition, it's like up to the time, but it will be relevant. Like you have to know the fundamentals, and it will be relevant. Freelancing website and how to get first client. Okay, this is an interesting question. Like so there are websites, but you won't get your first client, right? That's for sure. Like you have Upwork, and then there are few other sites. These won't get you your first client, because there are many people like in these websites then with experience, right? So I would suggest do your project first. Like come up with some idea, create your own project, publish in GitHub, have this profile, this portfolio in GitHub, like maintain 2-3 projects or more as well. Then in LinkedIn, be active and publish your work, right? And then in LinkedIn itself, like you can talk to people, like uh, for getting some, like I can do this. Like if you want any help, like I have this portfolio, I'm experiencing in doing these projects. You can like try out there, like talk to people personally, like understood. Like you don't like go and post in platforms and then just like randomly search. You have to publish yourself, you have to talk to people. Don't feel embarrassed, don't feel shy, go directly talk. Either they say yes or no, right? They don't say anything else more than that. Just like go, don't be shy, go publish and talk to people and bluntly say, I have these skills, I can work for you, give me this work if you have, right? I'm currently third year BTech ECE, but I'm interested in data science, how I should proceed. Okay, this is like very relevant to me. So I am from electronics background and I transitioned my career into AI. So like as an electronics student, it is much more relevant for us than computer science students, because in electronics you learn a lot of math. You have M1 M2 probability, and then you use more integration differentiations in your networks, or signal processing, everywhere. Like you use more AI without saying AI, right? So the fundamentals for electronics in their subjects are more. So you just like do understand your subjects, learn math more, and then do some projects in AI. Then you can like transition. That's how I did. Like, but most MNC companies prefer to do coding in the Python language. From my own experience, I mean mostly they are asking to do it Python firstly. Like, okay, so that's what like programming language never a constraint if they are asking in Python. But I never saw like whatever companies that I play for, or whatever companies that I do give interviews, that I can they are allowing me write in every language. It's up to me. They will ask me what programming language that you are comfortable with, and I am like can write with any, but they have restrictions. Then like do use that programming. But Python, Java, Python, C++, these can be like used. But one thing like programming language you can pick in a week, right? It won't take more than a week to pick up programming language, because you just have to know the syntax, right? That's all. How to create a list in Python, C++, Java, that's all. How to create a string, how to write a for loop, how to write a while loop, how to write a function. These are the fundamentals in programming. What else is there in programming language? Some companies are not ready to give an exposition level if they don't do in Python. Okay, so that's what, like if they are asking, they have a mandatory that you have to do Python, you have to learn Python. That's all. There is no there is no other excuse, right? Because that company is expecting a person should know Python. But the top companies, like the top product companies, never ask for this. Like Google, Meta, Amazon, Oracle, ServiceNow, these companies never ask for you in Python. Z Analytics easy if you know Python compared to full stack Java. Okay, so these are different like verticals. Full stack is like a full stack data. So basically, when it is coming to pay is better for full stack compared to data analytics, not data science, but data analytics. But learning curve for full stack is more than data analytics. So data analytics comparatively a little bit easier than full stack, because there will be a lot of moving parts in data analytics, like full stack. Data analytics is like it will be more straightforward compared to full stack in my opinion. I think I think we are over the time. So if you have any questions, you can reach to Sense AI, or or else you can reach out to me in LinkedIn. Like that's all from
Yeah.
my side.
So that was a nice insights. That was a nice session from you, Sri Ganesh. We as society thankful for your valuable weekend time for us, for our students. Thank you once again for having you here. And yeah, so my sincere thanks, and from our team, from our SSIT team and our founder CEO, Mr. Sudhir Reddy, a special thanks to you for being here. We would like to have you for our future AML collaborations. Sure, we'll work with you. Sure, we want you to be as a AML advisor for our company. We soon will reach out to you. Thank you once again for your valuable time.
Thanks for calling me. Thanks for having me here. So like if you have any questions, anything related to AI, you can reach out to me. If I know something, I can tell you. If I don't know, I can ask. I can do vibe coding like our people said, and tell you. Or else I can ask people and get to you.
Sure. Definitely, Sri Ganesh. Thank you once again.
Yep.
Yeah.
Thank you so much, everyone. Have a great weekend. Have a great Sunday night.
Thank you, my dear students. And last but not least, thank you for our team to making these sessions very smooth and functional. And a special thanks to our founder CEO, Mr. Sudhir Reddy, to establish this great platform to meet our industry experts with our students. Thank you. And once again, thank you, Sri Ganesh, for your valuable time. Thank you, guys. Thank you for joining. Next, we'll meet again with new career talk in the domains of ECE. Thank you. Thank you once again.
Thanks, everyone. Bye.
Bye.